see my screen. Okay, next question. Next question says, fill in the blank with an appropriate word, phrase, or symbol. If A is divisible by B, then A divided by B has a remainder of 0. Divisible, and I'm going to write this word down for you. Divisible means, and I'm going to show you with an example because this is the best way to show you, is 4 divisible by 2? Well, let's see. 2 will go into 4 2 times. 2 times 2 is 4. You always subtract. And that 0 remainder means that it is divisible. If you have a 0 remainder in a division problem, then that means that 4 is divisible by 2. 0 remainder equals divisible. Just write that down for that problem. Okay. Next problem. Now, if I'm going too fast, somebody raise your virtual hand or put in the chat. Slow down. But you don't have to write every single word. What you should be doing right now is going through your homework and pulling up these questions as I pull them up and filling them in. That's what you should be doing. Okay. Next. A natural number that is divisible by a number other than itself and 1. Remember, prime numbers are divisible by themselves and 1. So if it's divisible by another number besides itself and 1, what's the alternative to prime numbers? Composite. Now, these are all good standardized test questions, so you might want to make a note that these are all good standardized test questions. I'm going to turn my video off. I'm glad y'all got a chance to see me, but I'm going to turn it off for a while. Okay. Next question. The smallest natural number that is divisible without a remainder, that's what divisible means, by each number in a set of numbers is also known as the least common multiple. Dogs are not allowed in class. Get that dog out of here. What's that dog's name? Mutt? All right.
No, her name's
That dog looks so adorable.
What's his name?
Storm. It's a girl.
Oh, okay. Smallest natural number that is divisible. Okay, what does this mean? Okay, well, we're going to get into this when we get at the end of 5.1. So least common multiple, we'll get to that. Next. The largest natural is called the greatest common divisor. The largest number that divides each number is the greatest common divisor. So let me show you an example right quick. Let's say you got the numbers 2 and 7. Okay, 2 and 7. Well, it doesn't have a greatest common divisor because 2 is even and 7 is odd. So there is no greatest common divisor that will divide into 2 and 7. Now, if this was an 8, then you could say 2 will go into 2 and 2 will go into 8. But you can't divide anything into 2 and 7. So that's the GCD, the greatest common divisor. The biggest number that will go into two numbers. What will 2 and 7 go into? The smallest number, and that's called the least common multiple, that 2 and 7 will divide into. Anybody know that number? $14. Now, after we finish today, after I finish catching y'all up with these questions, guess what we're going to be doing? We're going to be doing the greatest common divisor and least common multiple. That's the end of 5.1. So we're going to be getting into that today. Next question. Which of these show all the prime numbers up to 100? All right, let's go to our handy dandy Google. And y'all should, okay, there's, how many is in here? Let's see. Hold on. We've got 20 in the class, 25 in the class, and 20 in the virtual room right now. So I'm talking to the two people that followed my directions Wednesday and went to Google and pulled up a list of prime numbers and put that on an index card. Let me guess. Miss Grindle, did you do that since Wednesday?
Yes, sir, I did.
I knew you would. I knew you would. Okay, so here it is. Heck, I bet there's people in here that still haven't printed out the outline. And that was 2 weeks ago. Here is a good example of prime numbers. 2, 3, 5, 7, all the way up to 97. Now remember, what did I tell you about 1 and 2? What did I tell you? And this was Wednesday or whenever. What did I say about number 1, the number 1 and number 2? What did I say about them? Anybody?
Some people don't consider those prime.
Say it one more time, Miss Goodman.
Some people don't consider those prime.
Exactly. Some books do not consider 1 or 2 or both or one of each, or some consider them both. All right. I consider 1 a prime number. But the reason we don't use 1 is because it doesn't help us with factoring. Because anything divided by 1 is itself. So that doesn't help us factor. So that's why a lot of books don't use 1. So if you've got this on your index card, along with, what else, Miss Grindle?
The divisibility rules.
Divisibility rules. Like I said, I bet maybe 3 people in the classroom did this. And I told Miss Grindle yesterday after class, yesterday meaning Wednesday, to take a black magic marker and mark out 4, 6, 8, 9, 10, and 12. Because those are all composite numbers and they're not going to help you in this section. Okay? So make sure you mark those off. Now, if you have your index card in front of you, that 2 or 3 of y'all did, then turn to the list of prime numbers and match that up with the question that they're asking. And I've got to find my problem. Where is my problem? I lost it. Great. Hold on a second. I'll find it in a second. There it is. All right. So which one? And that's A right there. So if you have your index card done, like I told you to do it, then that problem is a piece of cake because C is not it. Why isn't D the answer? Somebody tell me.
100 isn't a prime number.
100 is composite. So Charlie and Delta are no way and the answer. Now, you could include B, but since 1 doesn't help us with divisibility, you would go with A. So in this book, we're going to use this one. So what I would do, Miss Grindle, since you printed out, I would take a highlighter and I would highlight 1 and I would put over to the side, not used due to divisibility, because 1 does not help us with factoring. Okay, now this, I don't like these questions at all, is because these can be misleading and confusing. All right. Determine whether the following statement is true or false. 9 divides into 27. Now notice I inserted the word into. If you put the word into right there, you will not miss this problem. But some students, they can screw the way this is written. And I wouldn't do that. I'd just put an into right here, and I would rewrite it. 9 divides into 27. True or false? True. Okay, now that's pretty simple. I'm not going to spend a lot of time on that. You know your multiplication tables, and that's good. This one is the one that's the pain. 5 is a multiple of 20. That's not written correctly. It should be 20 is a multiple of 5. 20 cannot go into 5. And that's what that sentence is saying. Now, this one confuses students. Now, the best thing to do here is the following. When you see this problem right there, the best thing for you to do is to just write it out. 20 is equal to 1 times 20, 2 times 10, and 4 times 5. And then make yourself say, these are multiples of that. And that way you'll never get it wrong. These numbers right here are multiples of 20. 20 is not multiples of 5. These are multiples of 20. That's the best way to remember it. After you write out your multiplication tables, put these are multiples of 20. That's the best way to do it. Or I'm sorry, 20 is a multiple of 5. That's the way to say it. I do not test you on these, okay? Because I do not want to try to trick you. And 20 is a multiple of 5. That's the answer. Okay. Next. 36 is a divisor of 9. False. 36 does not go into 9, but 9 goes into what? 36. So that would be false. 9 is a divisor of 36. 9 goes into 36. 36 does not go into 9, unless you want a fraction. If a number is not divisible by 5, then it's not divisible by 10. Now, if you have your divisibility rules and you haven't marked them out yet, there's 5. 5 divides into 0 or 5. And down look at 10. 0. So if these two are zeros, then 5 and 10 will both be divisible into a number with 0 and 5. So that helps answer the question. That's why I told you to print it out and put it on the back of an index card, and that would be true. Okay, this one I really don't agree with because they should give you a multiple choice, not make you do every single one. I don't like the way they have this one written. The question is okay, but the way they've got it written is very redundant and too busy. It's just too much stuff. It says, use the rules of divisibility to determine whether 7,264 is divisible by the following numbers. Well, I'm going to do it this way. We're going to kill two birds with one stone. We're going to do our prime factorization, and then we'll be able to tell if it's divisible by these numbers. I'll show you. So the number that we're looking at is 7264. 2, 3, 5, 7, 11, and sometimes 13. And of course, I'm going to start with 2. You're going to start with 2 or 3 because those two numbers will just about go into everything except for 5, and it might, you might need to use it. But I'm going to go with 2 first. That thing looks like it's not focused. Hold on. That's better. Okay, so I'm going to divide 2. 2 will go into 7 3 times. That's going to leave a 1, so that's going to be a 12. 6 times. 2 will go into 6 3 times. 2 will go into 4 2 times. Still even, so I'm going to divide again. 2 will go into 3 1 time. That'll leave a 1 and a 6, so that'd be 16. So that's 8. 2 will go into 3 1 time, leaving 12, and that'll be 6. Now, I'm going to go ahead and tell you this, and you may not like it, but if you're having problems with what I'm doing and don't understand what I'm doing, then you're behind a little bit. You need to be able, and this is all people that have graduated 12 grades. You should be able to divide 2 into 18, 2 into 16. You should be able to do that. All right? You should not, if you are using a calculator to do this, you're going to be behind. And that's all I'm going to say. You don't need to raise your hand and say anything. I can't see what you're doing at home. Okay? So don't say I'm picking on you. I'm stating the fact. 2 will go into 18 9 times. 2 will not go into 1, so that's 0. 2 will go into 16 8 times. 2 will go into 9 4 times. That'll leave a 1, that's 10. And 2 will go into 8 4 times. 2 will go into 4 2 times. 2 will go in there 2 times, leave a 1. That'll be a 7. Now, why am I stopping? I'm changing gears because that 7 tells me that I can't divide 2 into 227. But I might be able to divide a 3. Now, why? Somebody tell me why I think you can divide a 3 into that. Anybody want to take a guess? I may not be able to. No, I can't. I was thinking of 27. 3 times 9 is 27 to get this number right here. Is there any other multiplication table that will give you a 7 other than 3 times 9? Any? Let's look at our multiplication tables. And I'm doing this for a reason, because a lot of people suck at them. So I'm going to go to my handy dandy Google, and I'm going to do multiplication tables. Look there, multiplication tables up to 15, because that's what everybody should know out of high school. That's not what I want. No, that's not it. Well, up to 15. multiplication, multiples, hold on a minute. Multiplication up to, multiplication tables up to 15. There we go. All right, let's look at this one. Look at there. Is there any number, any of these numbers in white right here, or the true multiplication tables right there, any of those numbers end in 7? I see one. 77. And that's 11. So 11 might go into, let's see, nope. 11 won't go into it. So any other 7s? I'm looking for a 7 in here. I don't think I'm gonna find one.
27.
I'm sorry, what?
27.
I said 27 a while ago. 3 won't go in there. 3 won't go in. 3 will go into 22 7 times, and that'll leave 17. 3 won't go into 17. So, but that's good that you saw it. I'm looking for another 7, maybe 117. That's too much. What?
Oh, yeah. I was
I'm
saying
sorry, what?
117.
Yeah, 117 won't go. That's too much. I think 227 may be prime. Is 220? No, yeah, 227 prime. I think it is. Yeah, one. Yep. I don't see anything that'll go into it. So that means 227 is 1, and this is the prime factorization. So somebody tell me what can go into 7264. Well, what's 2 times 2? Well, 2. What else? What's 2 times 2? 4, Hubert. Thank you, class. What's 2 times 2 times 2?
8.
What's 8 times 2? 16. And 16 times 2 is what? Or 16 times 2 is 32. So those are the numbers that will go into 7264 and 227, but they're not going to ask about 227. So let's look at the answers that they're giving us. Will 2 go into, yes. Will 3? No, I don't have a 3 right here. Let's bring this back in. Move this over. 4, yes. 5, I don't see one. 6, I don't see one. 8, yes. 9, don't see one. And 10, don't see one. And that's how you do that problem. So you see the transition, we're going into least common multiple, and you do this one. I want y'all to do this one. I'm going to give you a big one because I want to discourage you. So 86, 646. 86, 646, and I'm going to write it down for you. 86, 646. You might want to do a long table because that's a BA number. Or you could just quit. I'd quit if I was you. That's what I would do. You know why I'd quit? Because it's too big a number. You don't need to be doing big numbers like that. I'm going to have to fix this. I'm going to have to do something. I can't see y'all's chat while I'm looking at enrollment. Miss Roberts, yes, 8 is 1. I hope that's what you were saying because I can't. The context of your comment, I figure, is with this last problem. I'm not sure. It's a conspiracy is what it is.
Yeah, that's what it was.
Yeah. Okay. Thank you.
You're welcome.
2, 3, 5, 7, 11, and sometimes 13. Okay. If you can get this, that means you're a winner and you're supposed to be in the class. If you can't get it, that means you're going to end up in a cardboard box down by the river. I bet Miss Grindle has already gave up, right, Miss Grindle?
Gave up on the first day of class, sir.
Good job. That's the good answer. I like that. I'll tell y'all the story about the student that thought I was serious. I did that one day to a class. I did something to the effect, don't y'all know y'all can drop, you know? And that student wrote an email to the president. And the president at that time wrote an email back and said, this is what Hubert does all the time. It was so funny. He sent the email to me, not the email from the student. I didn't know who the student was, but he sent me the email back and kind of blacked out the student's name and came to me and said, look at what you're doing. You're making these students, they think you're serious. I said, well, I'll throw something in there that'll let them know they're not serious, that I'm not serious. People, y'all need a sense of humor. Good gracious. Like, I'm going to tell a student to drop my class. I would never do that. But I guess there's some teachers out there that are serious. I don't know. Maybe I'm in my own little world. And nobody's going to say anything. Okay. Appreciate the conversation. It's always nice to have interactive classes. Y'all suck. 2 will go into
You're welcome.
8.
Anything
4
I can do to
times.
help.
What?
I think we're still working on this problem.
Oh, God, you should have gave up 10 minutes ago. 2 will go into 6 3 times. 2 will go into 6 3 times. 2 will go into 4 2 times. 2 will go into 6 3 times. That right there is a yucky A problem. 43 323. Woo! We can forget 2, can't we? I'm going to try 3, and I'm going to do it in my head. 3 will go in there 1 time. 3 will not go into 13, so that takes care of that question. 5 won't go into it. 7 won't. Let's see. 7 will go into 43 6 times. That'll leave a 1. 7 will go in there. No, that's going to leave what? 6. 62. 7 will go into 62 8 times. That'll leave 56. 63. Okay, it is divisible by 7. 7 will go into 43 6 times.
I think the calculator disagrees with you there, Mr. Hubert.
Oh, I must have messed up.
Yeah, three
Yeah, y'all
can
shouldn't
go.
be using a calculator. I'm just kidding. On this one, you are allowed to use a calculator. Hold on just a second. I'm trying to find it.
3 can go into it. If you do 3 times 28,882, you should get it.
No, 3 goes into it.
Yeah.
Okay, I didn't go far enough. Okay, let me do 3 then. 3 will go into 4 1 time. That'll leave 13. 3 will go into 13 4 times. That'll leave 1. 3 will go in there 4 times. That'll leave 12 4 times and 1 time. Is that what you got? I'm sorry. Hold on.
You should end up with 28,882.
Wrong. I got what he got.
What I got or the teacher got?
No, what Mr. McClear got. That's what I got as well.
Yeah, you should get 14 441. Let me check.
think you guys are starting at different numbers.
Yeah, we're starting with different numbers, I think. And that's fine. I'm just checking. If everybody will hold on a second, y'all going hammy on me a little bit. All right, 43, 323. Clear. 43, 323 divided by 2 is wow. I've got something wrong. 43. Oh, I know what I did. I'm sorry, I didn't take the first number. That's my bad. Hold on a second. I don't work a calculator very good, and that's not a bad thing. That's a good thing. If you're not able to twirl a calculator on your finger like a basketball, that's a good thing. And I'm not good at a calculator. 86, 646, and a mouse divided by 2 is equal to 433.23, and divide that by 3. Yeah, 1441. It's not divisible by 2 because that doesn't end in an even number. We could try 3 again. Let's try 3 again in our head. 3 will go in there 4 times. I leave 24, and that would be 6 times. 1 time. I don't think 3 will go into it. 7 may go into it. 7 will go into 14 2 times. Not there. 7 will go in. Yeah, 7 will go in there, I believe. 7 will go into 14 2 times. 7 will not go into 4. 7 will go into 44. And that leaves 2, 21. Y'all check me. And let's see, 7 will go into, that'd be 14. That leaves 66. 56. I don't know about that one. I don't know. Let's try 3. 3 will go into 20 6 times. I believe 26. No. 20. I believe 2063. I wonder if 2063 is divisible by 7. And you could check with your divisibility rules, or you could check. These are bigger numbers, so I'm a little bit lenient. So 7 won't work. 11 will leave 96. Yeah, 96. And that'd be 88 to 96 is 8. 83. I don't think 11 will work. The only one left is 13.
What about 6? Shouldn't 6 work?
6 is not in our universe. Divided by 2063 divided by 13. Nope. So it looks like to me, has everybody tried everything but 5? I can't do 5 because 5 doesn't go into 3. So I've tried everything. Did y'all get this? Is that what y'all got?
Yep.
So we'll check to see if 2063 is a prime number. And let's just go to Google to check on that, because I don't think there's any charts that will tell you that'll go up to 2063. So I'm just going to go 2063. And let's see. I don't know if there's anything that says it's prime or not. It might be divisible by another big number, but not a, I don't know if 2000, I don't know if it's prime or not, and it's not coming up. And yes, it is a prime number. So our numbers that we can use is 2 times 3 times 7 times 2063, which we're not going to be asked that. So anything with these, you can actually, anything using those 3 numbers right there, you can actually use. So let's look and see what our choices are. All right, let me go to the question. So, is it divisible by 2? Somebody tell me. Yes, Hubert.
Yes.
There's a 2 right there.
Yes.
Thank you. Next. This is what I don't like about this problem. If they would just list the numbers and give you 2 or 3 dummies and put A, B, C, or D, that would be the best way to answer this question. Not asking every single one. Is it divisible by 3? Yes. Is it divisible by 4? No. Is it divisible by 5? No. And I'm having to keep looking over to these numbers right here. Now, is it divisible by 6? Yes, because what is 2 times 3?
6.
6, Hubert. Now, a while ago, somebody said 6 while I was doing prime factorization. I don't know if you were trying to answer this question, but 6 does not belong in when I was doing this. I was doing prime factorization. 6 doesn't work. Okay? Because
Yeah, I was just trying to
6
answer the question.
Okay. 6 does go into it because 2 times 3 is 6. Is that it? 8. There's no 8. And that's it. Oh, 9. No. How many more is it going to ask? Good gracious. I don't like these drawn out questions. Really? No. Okay. I don't like those questions because now we're getting to test questions. So number 13 is your first test question. Write that down. Number 13 is your first test question. So here we go. And somebody tell me when class ends. Let me guess. 1:15, right?
Yep.
Yeah, I figured. It's already
Yeah.
over time. See, time flies when you're having fun. Now, let me go ahead and tell you this. I want everybody to have 1 through 17 done, or questions sent by Monday. 1 through 17 done, or questions sent by Monday. Now, you shouldn't have to send me like those last 2. I could understand you sending me those last 2. What numbers were those? Numbers 16 and 15. I'm sorry. Let me go back. Okay, the last 2, that one and that one, I could understand you sending me questions on. But these wordy dirds, okay, 1 through 10, you should not have to send me those because those I answered with you. Okay, so 1 through 10, you should not have to send me questions on. If you do, if you still don't understand, that's fine. But most of them are wordy dirt questions or dirty word questions or wordy questions, and they are just words. So if you're going to send me questions, it should be 11 through whatever I said, 17 or 15, what was it?
17.
11 through 17 is the ones that could be on the test. I will not put those long questions on the test, but the material behind it, finding the least common, finding the prime factorization. 11 through 17, that's probably the questions you'll send me. And 1 through whatever I told you on the wordy problems, you should already have those done. All right, y'all have a good weekend. I'm going to shut down the recording, and I hope y'all get everything done. And I'm glad y'all got to see me today.